Standard 12 Chemistry Unit 3 Classification of Elements and Periodicity in Properties Part 8. Today we are going to learn about ionization enthalpy. As we know that when neutral atom loses electron, it is converted to positive ion or it is called cation. So here to remove an electron from the gaseous atom, to remove an electron from the gaseous atom in its ground state, and it is called ionization enthalpy. To remove an electron from the gaseous atom, so here energy is given and it loses electron and it is converted to positive ion. So here energy is required to remove electron from isolated gaseous atom. Isolated gaseous atom means what? The atoms should be free from the other atoms in gaseous state in its ground state. Here ground state means what? Lowest energy state possible for the atom. Lowest energy state possible for the atom, and it is called ground state. So here energy is required to remove electron from the isolated gaseous atom in its ground state. So here energy is given means what? Value of ionization enthalpy, and it is denoted by delta suffix I. H is always positive value. Value of ionization enthalpy is always positive, and its unit is kilojoule per mole. Second thing, what is first ionization enthalpy? Here energy is given, it loses one electron and it is converted to positive ion. So energy is required to lose one electron and is known as its first ionization enthalpy. First ionization enthalpy, delta I H1. This first ionization enthalpy. Energy is required to remove one electron or to lose one electron is known as first ionization enthalpy, delta I H1. When it loses energy required to loses 2 electron, and it is called its second ionization enthalpy, H2, and it is converted to being +2 charge. Energy is required to remove 3 electrons. Here it loses another electron, and it is called its third ionization enthalpy. And the another point that the factors affecting on ionization enthalpy, i.e. ionization enthalpy. Number 1, its atomic size. Number 2, its nuclear charge. Core orbital. Core orbital means what? Here, for example, this is the nucleus. It's a first shell, its second shell, its third shell. So for third shell, second and third shell, and it is called inner core orbital. Okay, these two orbitals are inner core orbital. Number 4, effect of SPDF orbital. As we move from S to P to D to F, its effect is decreases. And number 5, this concept we have already discussed, at electronic configuration. So there are 5 factors affecting on ionization enthalpy. Number 1, atomic size. Number 2, nuclear charge. Number 3, core orbital. Number 4, effect of SPDF. And 5th, electronic configuration. Now the general trend across the period. In period, as we move from left to right, ionization enthalpy is increases, or in a group, as we go down, ionization enthalpy is decreases. So for these trends, we have to consider 2 factors. Number 1 is attraction of electron towards nucleus, and number 2, repulsion of electron from each other, or in another word, electron repulsion. There are 2 factors to understand. In period, as we move from left to right, ionization enthalpy is increases, or in a group, up to down, its ionization enthalpy is decreases. To understand these trends, let's see about the shielding effect, or it is another name is screening effect. For example, lithium, its electronic configuration is 1s2, 2s1. Now it's is a nucleus, it is first cell and the second cell. This first cell and this second cell, or its first cell or 1s orbital is completely filled by the electron, and here for the valence electron is valence. Why it is called valence electron? Because its last electron remains in outermost orbital, and that is 2s orbital, so it is called valence electron. And for the 2s orbital, first cell or 1s orbital is inner core orbital. The effective nuclear charge experienced by the valence electron. Why? Nucleus has proton, and because of the proton, nucleus contains positive charge and electron has negative charge. So effective nuclear charge experienced by the valence electron will be less than actual charge because of the shielding. It is inner core that shielded the effective nuclear charge. So here effective nuclear charge experienced by the valence electron. Valence electron means what? Electrons remains in outermost orbital in atom will be less than actual charge on the nucleus because of shielding or screening effect. Of valence electron. From nucleus by inner core electron of the inner orbital. Now the general trend for in second period of ionization enthalpy. For second period, the elements are lithium, then beryllium, its atomic number is 4, for boron is 5, for carbon 6, for nitrogen 7, for oxygen 8, for fluorine 9, and for neon is 10. This is the general trend. When we move from left to right in a period, its ionization enthalpy is increases, but its actual order of ionization enthalpy is here. First of all, lithium, then less than boron 5, and then beryllium, then carbon 6, and then oxygen, and its atomic number is 8, is less than nitrogen 7, is less than fluorine 9, and it's less than neon 10. So here the trends is different. 3, 4, 5, 6, 7, 8, 9, 10, but here the trends is different. Why? So here the question is very most important. Explain why beryllium has higher ionization enthalpy than boron 5, its atomic number. Okay, or in another word, ionization enthalpy of the beryllium is greater than ionization enthalpy of the boron. First of all, let's see the electronic configuration of beryllium. Its atomic number is 4, so its electronic configuration is 1s2 2s2. Its atomic orbital is completely filled. 2s orbital is completely filled, while in case of boron its atomic number is 5, 1s2 2s2 and 2p1. Here 2p orbital is half filled orbital, and here 2s is completely filled and 1s also completely filled orbital. So beryllium here 1s2 and 2s2. Now during ionization what happen? Electron is removed from the 2s orbital in beryllium, while in case of the boron 1s2 2s2 and 2p1. So electron is removed from the 2p orbital. Here electron is removed from 2p orbital, while in case of beryllium electron is removed from 2s orbital. Here in case of beryllium, suppose is beryllium is 1s orbital and it is 2s orbital, and in case of boron is first and second orbital and equal to 1, and it is 1s orbital and it is n equal to 2. Here 2s and 2p orbital. Okay, 2s and 2p orbital. The penetration of electron in beryllium, there are 2 electrons, and here the penetration of electrons in 2p orbital is 1 electron. Here in case of boron, 2p is more shielded by the 2s and 2p 2s and 1s orbital, so it experiences the less effective nuclear charge, while in case of beryllium it experiences more nuclear charge. And from this 2s orbital, it is difficult to remove an electron from the 2s orbital, while in case of the boron, 2p orbital experience the less effective nuclear charge, and for this reason its electron can be easily removed, or less energy is required to remove an electron from the 2p orbital, and therefore the ionization enthalpy of the beryllium is higher than ionization enthalpy of the boron. And the second trend, ionization enthalpy, first ionization enthalpy of the oxygen is less than greater than first ionization enthalpy of the nitrogen. Oxygen, its atomic number is 8, its electronic configuration is 1s2, 2s2 and 2p4. Here in 2p orbital, 2p px, py and pz orbital, there are 4 electrons in 2p orbital, while in case of nitrogen its atomic number is 7, 1s2, 2s2 and 2p3. There are 3 single electron or unpaired electron in px, py and pz orbital, and it is half filled orbital, and half filled orbital is more stable. Half filled orbital is more stable. So here second thing, out of the 4 electron, 2 electrons experience the more electron repulsion, more electron repulsion. Okay, so electrons can be easily removed from the 2p orbital of the oxygen, while in case of the nitrogen its half filled orbital, that is very more stable, and because of this it requires more energy to remove an electron, and because of this reason ionization of the oxygen is greater than first ionization enthalpy of the nitrogen. And the last question for this part: what is the order of first ionization enthalpy, second ionization enthalpy, and third ionization enthalpy? The order of the first ionization enthalpy, sorry, here, or it is less than, or in second trend, third ionization enthalpy is greater than second ionization enthalpy is greater than first ionization enthalpy. Is the order of ionization enthalpy, because of the positive charge attraction increases. So more energy is required to lose electron. Okay friends, so next time we will discuss another topic. Thank you very much.